Hey there, TouchDesigner developers. DiLaura here with the Interactive and Immersive HQ. In this video, we're going to build an integration of sorts between TouchDesigner and GPT-3, which is a deep learning-based language model that generates surprisingly human-like text. So just as an example here, we've sent in a prompt for generating a simple backstory for the banana.tiff image file that we all know and love. And apparently TouchDesigner was developed to create interactive 3D models of bananas. So here's one more example of a response that was generated by GPT-3, telling us a little bit about Elbers's backstory. He's apparently known as the Bard of TouchDesigner and was born in a small town in the Canadian Arctic. So you can have a lot of fun with this. And so without further ado, let's jump into putting this together. So before we can even get into TouchDesigner, we actually have a little bit of homework and housekeeping to do. And you're going to have to start by creating an account on the OpenAI website. So OpenAI are the developers of GPT-3 and a number of other interesting tools like ChatGPT, which you may have heard of with all the press around it recently. So you're going to head to their website, which is openai.com. I'll link this in the description below. And then you'll head to this link that says API. After that, you have the ability to sign up by clicking this link in the upper right corner, and then you can create an account for yourself. Note that this is an API and a service that does charge money. It does cost something to use. However, they give you a stipend of sorts of $18 when you first sign up, which, although it seems like not that much, actually will give you more than enough opportunity to experiment with these tools, as most of the prompts that I was sending in and generating text from total maybe costs like 1/100th of a cent or maybe half a cent for the most expensive ones that I've seen. So you really can generate a lot of different results with that little grant or stipend that they're giving you at the beginning. So you also do not have to provide any financial information like your credit card or PayPal or something like that up front. So don't worry about that either. They do make it really easy to just get in and get working. So once you have created your account, you should be able to then log in, and I think you'll see something like this, the overview page here. And then you'll want to, as you're setting it up, I think they will prompt you to generate an API key, which is how you're going to access the software, or the API rather, when we are connecting to it via TouchDesigner. So this is like a special key, like a password or something that tells OpenAPI, this is this person's account trying to access it, and gives you the authentication you need to actually use their APIs. So you're going to be prompted to save that key somewhere on your machine. So save it in a text file and keep it safe, and also have access to it, because we're going to need to copy it and use it within TouchDesigner to be able to access the API. The other thing that we're going to have to do is to install the Python library that OpenAPI has created, or OpenAI rather has created, to access their APIs. So if we go to the API reference section of the documentation, so that's just one of these tabs up at the top, we can scroll down to API reference and hit introduction. You'll see here they have a couple of ways to install this. We're going to be doing the Python library, and we're going to be doing this as an external Python library. At least that's the way the code that we're going to be working with is written. So if you haven't yet set up your copy of TouchDesigner to work with an external Python environment, or have no idea what I'm talking about, I would recommend taking a look at this great resource that Matthew Reagan put together for the TouchDesigner Summit in 2019. This will again be linked in the description below, which gives you a great overview of why you might want to work with an external Python environment and access your libraries in that way, how to do it. And besides all of the great in-depth text, we also have a ton of videos that cover the same content in probably even more depth. So go ahead and take a moment to get the account created and go through this content and get your external Python environment set up. Once you have done that, you can come back and use this pip install command within that either terminal or command prompt window to make sure that that library is installed. And then you'll also likely have set up TouchDesigner to, in the preferences, be pointing to an external Python module path. So anyways, check out those resources. Links are in description below, and then meet us back here for the beginning of our project. So we have gotten our OpenAI account created. We have set up our copy of TouchDesigner to work with an external Python environment and access its libraries that we will have installed. And we will also have installed the OpenAI library. So now we can start building our functionality within TouchDesigner. So the first thing that we're going to do today is to add a base comp to our network, which is going to contain all of the different code and functionality to access the API. So I'm going to call this base GPT3 so that I know what we're going to be doing with it. And then I'm going to right click on it and hit customize component because we're going to add some custom parameters. So we are going to be adding a couple of different things. First of all, we need to add a parameter page. So I'm going to do GPT-3 settings as my title here and hit add page. From there, we're going to add 4 different parameters, which allow us to kind of tweak the response or the prompts that we send to the GPT-3 API and thus the results that we receive from it. The first one is called the prompt, which we send, which is basically a string of text that we use to generate some kind of result. So we need to set this to a string data type, and then we're going to name it prompt and hit add parameter. Our second one is called max tokens. So I'm going to type that in. And we'll take a look at the actual definitions of these in the documentation in just a second. We'll just kind of put it together first and then kind of review. So max tokens is going to be an integer, and then hit add parameter. I'm just going to click over here on this parameter window over to the tab where we're adding these parameters in so we can confirm that they are correct. After that, we're going to have one called temperature, which will be a float. And I'm going to hit add parameter. And then after that, we have finally one called send request, which is a pulse button. So let's set that to pulse. Okay, so we've got our parameters all set up, and so we can close out of this component editor window. We will take a look at what the top 3 here actually mean in the documentation when we actually start writing the code in just a moment. But for now, we're just going to add a couple of other operators within this base comp. So I'm going to double click on that to head inside. And the first thing that I'm going to do within this is to add a textstat, which is going to be where our API key lands. Now, this is maybe not the way that you want to do this if you are, making this TOE file publicly accessible or something like that, because there's no sort of encryption and anybody can gain access to your account if they have this API key available. But for the purposes of just getting started and getting used to working with this API, we're just going to place it within this text file. So what I'm going to do is rename this text file text space API and then a capital KEY. So we got text underscore API key. And then you'll go ahead and paste your particular API key in there. All right, so I've pasted my API key into that text stat. Now let's add a parameter execute, which is going to be the place in which our function call to the API will be generated from or called from. So first of all, we need to grab for the ops parameter here, we're looking at the parent operator, which again is the base comp. So I'm going to type in parent in that little drop down there and then open and close parentheses. And then I need to switch this to the expression mode so that it actually grabs the particular operator that is the parent. From there, I want to grab, actually, we really only need one parameter, but we'll grab all of them just in case you ever feel like adding more. So we're going to use the asterisk there to grab all of the parameters. And then I want to turn off the built-in switch here because we don't actually need to do anything with the built-in parameters of the base comp. From there, I'm going to open this in an external code editor so that we can add some code to it. So for the sake of time, instead of going the route of building an extension for this functionality, which honestly is the better way to go in the long term, we're just going to do our function writing within this parameter execute, which will still function and work perfectly fine. But if you were to take this further and say put it into a larger scale project, I would recommend taking this functionality and folding it into an extension. But as I said, this will work just as well for our use case today. So the first thing we're going to have to do is at the top of our code here, we're going to import the OpenAI library. So this is the Python library that we have installed into our external Python environment. And we are importing it here so that we can use it and make the request that we want to. So we're going to do a function call within this onPulse function in a moment, because remember we have that send request button, which is the kind of trigger that actually will send the request to the API for us. But right now, what we're going to do is define a function down here at the bottom that we will actually do the requesting of information from. So this will just be a cleaner way of kind of encapsulating that function. And at the same time, I think I will delete some of these other default functions that we're not using. They're easy to get back if you ever want to by adding another one of these to your network, but I'm just gonna kind of take it down just to the onPulse function because that's all we need in this case. So let's define a second function here, which is going to be called submit request. And then I'm going to do open and close parentheses, colon, and then I want to make sure I add my return statement in there as well. We don't need to feed anything into this function. We're just going to have it grab all of the different parameters that it needs from the base comp. So now that we have the basic structure in place, let's head back to the API reference that we looked at for a second. So we've already done our installation of the library, obviously, which should have happened at the beginning. But the next step in accessing this API is to go through the authentication stage. So basically, that means we have to send over or set our API key within the code so that OpenAI can then authenticate us and grant us access to the API. So if we scroll down here to the this Python package section, this is example with the OpenAI Python package. Again, we're going to be doing stuff exclusively in Python right now, so this is the relevant example for us. You can see that we have, first of all, we have to import this library, which we have done, and then we have below that OpenAI.API_key. And then here we set that equal to wherever our API key is located. And again, in our case, that's going to be the text stat that we set up. We don't need to worry about the OpenAI organization because we, well, at least I haven't set up mine with multiple organizations. If you have an account already and have done so, you may have to specify one, but I only am using one. And if you have a new account, you likely are too. And we're not going to worry about this listing function call here because we're going to have a specific model that we're going to use. So let's head back to our code. We're going to use this line here to set our API key. So, all right, let's go ahead and type in OpenAI. So we're accessing that library that we've imported. And then we need to set the API underscore key equal to. So we need to now access the text stat that we set up. So remember, we called it text underscore API key. Mine I did with a capital K. Make sure your spelling is the same as the operator. And then I'm going to grab the text of that operator. So I've typed in .text after the operator reference, and that will send over or provide the text as needed. So, oh, and you don't want to add any autocomplete stuff to the end. So just .text. Then we're going to we're going to set up some variables that we will store in some of the parameters from our base comp into, which we'll again use for this request that we're sending over to the API later. So I'm going to enter my first one here, which is called prompt, similar to the custom parameter that we set up. And then I'm going to access the parent operator again. So I'm setting that equal to parent, open and close parentheses, and then .par. And because that was a custom parameter, we need to use a capital letter for the beginning of that. So parent, open and close parentheses, .par, capital P prompt. And again, don't let your autocorrect change the spelling of that for you. You will need the capital letter, otherwise it won't work. Then we have max tokens, and we're going to set that equal to parent, .par, max tokens. Again, very similar spelling, but the capitalization is important here. So make sure that only the first letter is capitalized and nothing after that. And then after that, we have our final parameter here, which is we're just going to do shorthand temp for temperature, and then parent, open and close parentheses, .par, .temperature. Okay, great. So let's flip back to our API documentation again. I'm going to save just to make sure that I don't lose this in case something were to happen. So let's actually dive into this API documentation a little bit more so we have a clearer understanding of what is actually going on. So we have set up our authentication, and now it's time for us to actually make a request to the API, and that will again provide us with the text generation that we're looking for. So this is giving us a number of different examples of different ways of inputting a request and the kind of data that you'll receive back from the API. We'll look at the response a little bit more in detail once we've actually received one ourselves, but let's head down to the completion section where we can just kind of briefly look at creating a completion, which is the type of function that we'll be using within this API to generate text. So the first thing that we have to do over here, we have a number of examples which by default are not using the kind of Python library version that is available. So all you have to do to see these in Python code is to click this little library option over here and switch it to Python, and then all the code from there on out will appear in its Python form. So you'll notice here we are importing the library, and then we are setting our API key, which we have done. And then we have our request. So we're accessing or we're sending this request over. We're specifying a number of different things, including a particular model. So this is like the model that we are using. And if we take a brief look here, using this link, there are a number of models that they have put together and trained that do different things, basically going from least advanced to most advanced. So the DaVinci model at the top here is the most advanced and can generate the most complex kind of outcomes. And then from there, it just basically gets simpler and simpler for more straightforward use cases. The other thing to note is that the different libraries have different costs associated with them. So let's just take a look at that on this pricing page, which again, you can access in the API reference or the main OpenAI page via the pricing tab. So I've kind of scrolled down here to the language models, which is what we're looking at. And you can see here that for basically half a cent, we can get 1,000 tokens for these two libraries here on the left, which again are the kind of lower tech or not as highly complex versions as some of the libraries here on the right. So even with this DaVinci library, the most powerful one, we only spend 2 cents on 1,000 tokens. So as they say here, you can think of tokens as pieces of words where 1,000 tokens is about 750 words. This paragraph is 35 tokens. So basically what this is saying is every time that we are sending a request to the API and it's providing a response, we are using up a number of tokens that are assigned to our account. We got that $18 worth at the outset of creating our account, which means that we have basically many thousands of tokens available to us, even if we're using this most powerful library. So basically, depending on how much text is in the prompt that we're sending and how much text is in the result that we're receiving, we'll use more of these tokens. But as you saw from the requests and the responses that I was showing in the outset of this video, none of this stuff was even close to using 1,000 tokens. Like we were generating very short responses, and thus we're really not using that many tokens. Another thing that is useful to look at is there is something called the tokenizer, which I believe is accessible maybe in the introduction here. Yes. So in the introduction section of this documentation, you can click on this tokenizer tool, which you can use to get an idea for how much text is equivalent to how many tokens. So again, this is like a kind of arbitrary or complex system that the language models are using to kind of break up this text. So it's not necessarily something that's intuitive right off the bat, but you can use this to just get an idea of like this short sentence that I've written here. We're creating a TouchDesigner example for GPT-3 period. That's only 13 tokens. So remember, 1,000 tokens, even of that DaVinci library, is 2 cents. So this is again not not that much in terms of the number of tokens that it would be using up. So hopefully that gives you a better idea of those aspects. What the tokens are relating to and kind of how to think of them in terms of quantity. And let's just go back to that completion section so we can, again, dive into these components. So we've gone over what the model is. We kind of maybe have an idea of what the prompt is. You can see here the prompt is basically what is being used to generate completions for. So this can be a number of different things. We're just going to focus on this as a string. So this is what we're using or sending to this model to generate text from. Then we have max tokens. Again, we're keeping this kind of simple for this example. So the maximum number of tokens to generate in the completion. So what this means is it's almost like a limit to the word count or the number of characters in the results that you're receiving. And it's nice to be able to limit this because you can get a better chance of controlling, how many tokens you are willing to use per result, and thus how much of your little stipend you're spending on each API result that you're receiving. So again, we're going to use this as kind of a limiter of how many words we're receiving. And then finally, we have temperature. So temperature is, as we can see here, what sampling temperature to use. So higher values will make the output more random and lower values will make it more focused. So this is something you'll have to play with to get used to. It kind of will affect the creativeness and craziness sometimes of the outcome. But it's a useful parameter to be able to tweak to see what kinds of impact you can make. And that is it for what we're going to be using for our particular example. Obviously, there's a lot more you can dive into, but for the sake of time, we're going to cut it at that. So basically, let's just go ahead and copy this portion of code here and bring this back into our code. So after our temp section, we're going to paste that, and I'm going to kind of adjust the alignment here so that it matches what's going on, because obviously this is Python and we need everything to line up and be spaced correctly. So we are creating a completion request with this section of code. We're going to stick with this DaVinci model, although again, you're welcome to change that if you don't want to use it. I just find that it provides the most interesting results. For the prompt, we're going to want to use our prompt variable that we set up. And so for that, we're going to use some handy dandy Python f-string formatting to insert this and convert it into a string. So what I'm going to do here is delete, say this is a test, and then add the letter F and 2 single quotes. And then I will put some brackets, or some curly braces rather, and type in prompt, which will automatically format that correctly when the code is run. We're going to basically do exactly the same thing for the max tokens and temperature, except that we're going to convert them into the data type that they need. So for max tokens, I'm going to add that f-string formatting again, except this time I'm going to, and let me just increase the size of this. Hopefully that'll make it a little bit easier for you to see. And I'll move it up so that thing at the bottom of the screen doesn't get in the way. So for the prompt here, again, we're going to be looking at the max tokens variable this time. So I want this one, which is referencing that variable we set up there. However, I want this whole line of code here to be typecast as an integer, because it will provide a string to start out. So I'm going to encase that or enclose that in some parentheses, and then use the int Python function to convert that to integer. Then we're going to do exactly the same thing for the temperature, except we want to convert it to a float. So I'm just again copying and pasting what I've written for the max tokens portion of this, and then I'm going to first change what variable we're inserting to temp, and then I'm going to change this portion that says int to float to convert that to a float value. So let's go ahead and save that, and then we actually need to add another operator before we can write our next line of code. So we're going to basically use a text stat to basically take our response and place it into the stat for us to do some additional kind of processing. So I'm going to add a text stat here, and then I'm going to rename that to text space response. So again, that's where our response is going to be stored. So add that to your network, and then bring your code back up. And we'll add another line of code here and type in OP. So we're accessing this text response operator now. So I'm going to do text underscore response. And then I will set the text of that, so dot text, to, and we're going to use, actually, oh, we did forget to do something. We want to set this this call that we're making to the API. We're going to store that into a variable called output. So let's set output equals, and then we'll do the OpenAPI call right there. So again, just make sure you add that in, and then we're going to set this text equal to output. So we're going to take whatever we receive back from this function and store it as text into this DAT. So what I'm going to do right here is scroll back up to the first line of code that we wrote, and we'll just allow you to get a nice clean shot of this to make sure that you've got it all copied down correctly, and then make sure you save and head back to TouchDesigner when you are ready. Okay, so we have our code written. We have a place for our response to land when it is received. We can actually now test this and see if we're able to generate anything from the API. So I'm going to head back up a level by hitting the U key, and then in our prompt, I'm going to type in, I don't know, write a description for the software TouchDesigner. You can literally send it anything that you want, and it will do its best to generate something. So I've added that in as our prompt, and we've gotten an error. Let's double check and see what's going on here. So cannot find function named on value change. So when we deleted the different functions from the parameter execute, we forgot to turn off the corresponding value change switch. So it's still looking for a function basically that doesn't exist. So go ahead and turn that value change switch off, and then head back up a level, and we can just hit clear children's script errors to make that go away. So we have a prompt, write a description for the software TouchDesigner. I'm going to set my max tokens here. We don't need this to be all that long, so maybe to like 30 tokens. And again, you can use that that example on their website or the tokenizer tool to kind of get a sense for what you are looking for. I'm going to set the temperature to something high for it to be a little bit more random and creative. So I'm going to set this to 0.8. Again, lower values will introduce less randomness and maybe less silliness in certain cases. And then I'm going to hit the send request pulse button. Now, it doesn't look like anything has happened. Let's go take a look. It appears that we have not done anything. And that is for a very good reason. We have never actually called this function within our code. So, okay, bear with me, folks. Let's just go back to our code. We have to, of course, tell our code when we receive that pulse from that parameter to call this submit request function. Otherwise, it's just going to be sitting there and doing nothing. So within this onPulse function, let's type in if par.name equals, and then the parameter's name that we set up is called send request, and then colon, we need to run this submit request function. So submit request, again, we're using the exact same capitalization that we have here, and then open and close parentheses to tell the code that that is a function that we want to run. So let's save that, head back to TouchDesigner, head back up a level, and hit the request button. What you should see now is that TouchDesigner has frozen for a moment as it's accessing the API. Being that things are single threaded in TouchDesigner, that means that it kind of halts everything as it is accessing the API and or sending the information and receiving it back, which we're going to talk about in a second. But if we head inside, you can see that now our text response has some content in it. So it says TouchDesigner is a real-time visual development platform for creating professional media and interactive design, blah, blah, blah. So you can see here we have it cut off at the end here, probably because of our token, a max token that we've set up. So again, that's like kind of like a max character count, so to speak, that you can control. And let's now take this data and kind of format it into something that is more useful for us. So this is, again, in like a JSON formatted style. So if we take, or if we add a JSON DAT to the network, you can see that immediately we've added some kind of like context highlighting and formatting to this text, which is very helpful. So from there, we can actually use and evaluate DAT to basically parse through this information and grab the component that we want. So really the only thing that's useful in this response, even though it tells us some good information, is the text. We're here for the text and we want to do something with the text. So within the evaluate dat, we are going to add a line of code in this expression parameter. So I'm just going to kind of make this a little bit bigger and then click the drop down here so you can see what I'm writing in. So first of all, we're going to access the operator called JSON1. So op, open and close parentheses, single quotes, JSON1. Then we want to type in .source. And then you'll notice here that we have in this sort of first tier of our results, we have choices. So if we want to access choices and what choices contains, which is basically like a little dictionary of content here, we can access choices by using a set of brackets and then typing in single quotes within those and typing in choices. So if we do that and we click off, you can see that then we have ourselves basically this dictionary written out as a single line in a table. But again, we just want that text and nothing else. So let's go there and grab the text first. So the way that we have to access that is by adding a second set of brackets and putting a 0 in that pair of brackets, which is basically saying, okay, choices itself is a list or a collection of information. We want the first item, which is this dictionary. And then now that we have kind of grabbed the dictionary specifically, now we can go within the dictionary and access this member here called text, or this key phrase called text. So I'm going to add another set of brackets here, single quotes, and then text within those single quotes. There we go. There is our text. Now you might have noticed that there's a couple of spaces at the beginning of this line of text. And if we look at it back within this JSON file, we have new line characters here, which again, we don't really need. We just want the text without that sort of formatting. So at the very end, I'm going to use yet another set of brackets and do some little bit of Python formatting. We're going to start with the second character, or the third character, actually index, the third index here, which would be the T in TouchDesigner. And then we want to grab the entire rest of the string from there. So as soon as we do that, the spaces disappear and we have a nice clean string accessible to us. So great, we have the text as a table, a cell within our table, and now we can output that text into the rest of our network. So I'm going to use an out dat here, and that will again allow us to send this text outside of our base comp. Now, that is basically it for the GPT-3 library accessibility and creating this little component here, but we're going to push it a little bit further and we'll talk about why right now. So you might have noticed, okay, great, we're getting this text, but if I want to create like a real-time animation, or if I'm doing anything within TouchDesigner, let's say, for example, I have like a noise that is a noise top that is animating, and I have some other stuff happening in the background. So again, you don't have to do any of this right now. This is just for example. Let's say I've got this colorful noise and I've got an animation and stuff is moving around on the screen. If I just go ahead and click this send request button to our GPT-3 library, you can see everything freezes within TouchDesigner due to that single threaded nature. And so that is not really ideal if we're trying to do any sort of real-time animation with TouchDesigner, which is what a lot of us are trying to do with it. So the reason that we have encapsulated all this functionality in this base comp here, besides the fact that it just kind of makes things a little bit easier to access, is that we can then save this as a external tox file. So I'm going to save the component tox right here. And you can see I already have one from an example I did before. But if I name this something like, I'm just going to call it base GPT-3 and then REC, because I'm doing it during the recording of this video, but you can just call it base GPT-3 or whatever name you want and hit save. we can then utilize something that may be new to a lot of newer users, which is the engine comp. So you can see here in the description at the bottom, the engine comp runs a tox file in a separate process. It uses Touch Engine to manage these processes and pass data between the loaded component and the main project. Okay, cool, but what does that mean? So the engine comp allows you to basically, it almost acts as though we have a second instance of TouchDesigner running, and then allows you to do those things like this API call in Python processing in a separate process, meaning that our noise here will be able to keep animating, and anything we're doing real time will not affect the frame rate and the performance here in this instance of TouchDesigner. So let's go ahead and set that up and see how it works. So if we click this little plus sign on the right of the tox file parameter, we grab in this one that I've just saved, we have an error, which is telling us that it is loading. So it's just a little warning there. So cool, that is loaded up and ready to go. So once it loads, you'll notice that we now have that page, GPT-3 settings, that we set up with our custom parameters. And that's one of the cool things about the engine comp, is that whatever you kind of set up as custom parameters for your talks at this kind of like highest level will appear and be accessible to you in the engine comp parameters as well. Another thing to note is you can't go inside of the engine comp, so you can't really view anything that's going on within it. But again, it'll allow you, just like a regular comp, to have inputs and outputs. So if we connect a null to the end, or the output of our engine comp, you can see that we have the same line of text that we saw in this original base comp that we set up. So what I'm going to do here is I'm going to stop this one from cooking. You can even, so long as you have saved, which I'll do now, you could even delete this one from your network now that it's saved as an external tox. But the point that I want to make here is that let's just, let's write a prompt here and then send that request over. So I'm going to write a description for the software. I don't know, we'll write one for Notch. And then I'm going to click send request. What we should see is that there is a request being processed in the background. You can see it just updated there, but nothing happened with our noise top and nothing happened with our timeline. We were able to keep things running without having that pause and hiccup in performance. So rather than making the video even longer by going through the whole process of setting up the very basic user interface that I showed at the beginning, I think I'll just show you what the network for that looks like in case you're interested in building it for yourself. It's super basic. I'm just using the text comp here on the left and the right, which, if you're not familiar with, has the ability to work as an editable text field. And then I'm basically taking the text parameter. I'm using like a chop reference with the prompt parameter that we set up within the engine GPT-3 operator. And then I am taking the response, which is in this table. And then over in the response text comp, I'm just, again, using a chop reference to grab that text and display it in the table. The only other thing that I have is a container with the two labels, and then all of that is within its own container, which is how we kind of build interfaces in Touch. So again, it's super simple, not that interesting, but I thought I would show it to you in case you're looking for a way to start exploring for yourself. Obviously, there's a lot that you can do in terms of cool generative visuals or other sorts of interactive components here within Touch, but the rest is up to you and your own imagination. So hopefully this has shown you the kind of possibilities of GPT-3 working with APIs in a pretty simple sort of way, as well as the engine comp, which is, again, not a topic that beginners are probably as familiar with, but one that is a super useful tool that you have in your TouchDesigner toolbox. So with that, we're going to close out the video. Hope you have enjoyed putting this together. Looking forward to seeing you in the next one. Thanks so much for watching.
Hey guys, thanks for watching. If you're serious about taking your TouchDesigner and interactive skills to the next level, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for TouchDesigner and interactive professionals. You can learn more by checking out the link in the description. And if you like this video, don't forget to hit that like button. And if you're new here, don't forget to hit subscribe and the little bell icon for more awesome free content.